1,000 times more massive than the Earth. Jupiter could swallow all the other planets in the solar system twice and still have room for more. But this giant is getting smaller.
Gravity is still bringing all of the gases and liquids together. And that heats up the interior of Jupiter.
This heat rises up to Jupiter's surface and escapes into space. The planet cools and shrinks, making the gas giant a third smaller today than when it first formed. As the planet cools, the shrinking slows, from an inch a year in its infancy to just a few fractions of an inch today. It could continue shrinking for 1,000 billion years. Even then, it will always be the solar system's biggest, most powerful planet. Jupiter is shrinking too slowly for us to see, but we can see the effect of this rising heat.
This is actually one of the reasons Jupiter has the spectacular weather, all of those beautiful bands of clouds.
On Earth, the sun's heat drives our weather. Switch off the sun, and our weather would stop. But Jupiter's weather would keep on going. Its weather doesn't come from the sun. It comes from deep inside the planet itself. Heat rises up through the boiling soup of gas, creating Jupiter's spectacular swirling clouds. And the whole time, the giant planet spins. At 29,000 miles an hour, Jupiter rotates faster than any other planet in our solar system.
Jupiter rotates on its axis about once every 9 hours, compared to a 24-hour day for us. So huge superheated clouds from the interior get smeared out by the rotation, and we have the beautiful cloud tops of Jupiter.
This marriage of heat and motion spawns a monster.
Jupiter's red spot is a gigantic cyclone larger than the size of the Earth and has been rotating stably with winds in excess of 250 miles per hour for over 3 centuries. Imagine a storm that lasts for 300 years.
On Earth, cyclones die when they hit land, but Jupiter has no land to stop its storms, almost unlimited heat to fuel them, and a rapid rotation.
Jupiter is basically stoking the fires of the Great Red Spot. We're used to storms growing and then going away on Earth, but if they're spinning the right way, because Jupiter is so big and spinning so quickly, they feed into each other, and it keeps the storm alive.
Long after the other planets freeze and die, Jupiter will still be pumping out heat, driving its monster storms. Thanks to its immense size,